Hello everyone, today I'm solving Leetcode question 51, N queens. This is a very classic backtracking problem. It's a hard problem. I think the hardest part for this problem is to understand the problem statement. I'm not a chess player, so I have no idea how queens attack each other, so it took me a while to actually figure out the rules. So let's first read through the problem statement, then I will explain that. The n queens puzzle is a problem of placing n queens on an n times n chessboard, such that no two queens attack each other. So the dimension for the chessboard is n times n, and then our requirement is to place n queens. No two queens attack each other. So what does it mean for queen to attack each other? So I searched the chess rules. Queen can move in all 8 directions, which means for a queen it can move horizontally, vertically, and then also diagonally. So all the 8 directions the queen can move. No attack means that queens sitting in different rows, columns, and diagonals. Otherwise, the queen can move and then to attack the other queen. So that's kind of the meaning for no attack. So basically, we need to place n queens on the n times n chessboard. And then when we place n queens, we need to make sure that the queens are sitting in different rows, columns, and diagonals. Given all the integer n, return all distinct solutions to the n queens puzzle. So basically, all the possible placement. Each solution contains a distinct board configuration of the n queens placement, where q represents queens and then dot represent empty space. So let's take a look at the example. For this first example, when n equals 4, place 4 queens on the 4 times 4 chessboard. There are 2 possible different solutions, and then it's represented as a 2 list here. So the first list contains 4 elements. The first element is the placement for the first row. So empty queen, empty, empty, dot, q, dot, dot. And then the second element represents the second row. 3 dots followed by a q. So that's kind of the output format. If n equals 1, then in that case you only have one way to place one queen. So now let's think about how to solve that. So it's a classic backtracking problem. So the idea is actually we start from the first row and then we kind of consider what are the possible placement. So we can place the first queen on any of the columns in the first row. And then we just move down the rows and then we keep track of the columns and the diagonals for queens already placed on the board so that we can avoid place the queen in the same columns or diagonals as the queens already placed on the chessboard so that we can avoid the queens attacking each other. So basically how to track queens in different diagonals. So that's another tricky part of this problem. So, but looking at the different types of diagonals, there are actually 2 types. So one diagonal is run from the up left to the bottom right. And then for this kind of diagonal, let's say if I move from the up left to the bottom right, let's say I follow this diagonal line. So the first cell has the index, column index 0, row index 0. As I move to the next cell, both my column index and row index increase by 1. So for this type of diagonal, when it runs from up left to bottom right, for each move, we got the index for row plus 1 and the index for column plus 1 as well. So this is true for all the other diagonal lines of the same type on this chessboard. For example, for this one, at the very beginning, the row index is 1, column index is 0, and then as we move down to the next row, the row index becomes 2, column index becomes 1. So it's still row index plus 1 and column index plus 1. So that's kind of the condition for all the grid cell falls onto the same diagonal line. For this kind of diagonal, I call it the diff diag. So that's how I name it, because the difference between row index and column index belongs to a fixed value. It's absolutely varied in different diagonal lines of the same type. Let's say in this case, in this diagonal line, row and column index, they are the same. So row index minus column index equals the fixed value 0. In this diagonal line, row index minus column index equals the fixed value of 1. But they are the same type of diagonal lines. We call it diff diag. And then there is another type of diagonal lines, so which runs from bottom left to the upright. So for each move, you can see here, it's actually row index minus 1 and column index plus 1. So for this cell, the row index is 3, column index is 0. For this cell, the row index is 2, column index is 1. So you can see the trend is row index minus 1, column index plus 1. So in this case, the sum of the row index and column index equals to a fixed value. So that's why I thought I call this type of diagonal line sum diag. So now we have figured out how to track the queens sitting in different diagonal lines. So we can start by solving the problem. So we got the n queens. Let's try to initialize the columns. So remember, we are trying to move down the rows, and then by tracking the queens already placed in the columns and the diagonals. So columns equals set, and then we have our diff diag equals set, and then we have our sum diag equals set. So those are utilized to track if we have already placed the queens on certain column index or certain diagonal or certain diff diagonal line or sum diagonal line, as we explained the two types of diagonal lines before. And then we also want to initialize the result to append the result to this list. Now let's move down the rows. That's our row index. So let's say, in this case, we just check basically for column in range n, if this column not in visited. So if this column index has not in this column set, which means no queen has been placed on this column, and then the I plus column not in sum diag, which means no queens has been placed on the same sum diagonal line, and row minus column not in diff diag. So in that case, we can place the queens in this row and column in position. So we start our placement. So in that case, Okay, let's try to put this one in a helper function. So basically this one is indicate and then I can just remove this one. So basically visit. So basically that's kind of how we start visit and then we are trying to add the columns into const add column index sum dag dot add I plus column and then diff dag dot add I minus column and then we can move to the helper. Let's say we can move to the next row. Oh, before move to the next row, we need to occupy this position as the queen. So in that case, we are trying to initialize a board. So at the very beginning, this board is empty. So basically, this is the n times n chessboard. We place the queen on the board. So I column equals queen, and then we start to visit the next row. So after visit the next row and then all the possible combinations starting from this row index I, we start backtracking. So by backtracking, we remove our column index and then we remove and then we also remove from the diagonal lines. Okay, in that case, basically the thing is, let's say when we are start with it, let's say there are many possible options. Let's say we're at I equals 0, the first row. So at the very first row, so there are n possible options to place this queen. We can place the queen here, and then also place queen here. So there are many possible options as long as the column index has not been occupied, and then no queen has been placed on the same diagonal lines before. So in that case, we can start the visit. So basically, let's say if we have to place this queen here, this is one possible options, and then we just like going down from and move to the next row with this kind of placement. So that's kind of how this part is working. And then after we finish that placement, after traversing through all the rows, we actually do backtracking, because there are still other options that we can place the queens. What if we place the queens here? So that's why when we do the backtracking, we want to put the configuration back to the original ones. Let's say by remove that queen. So let's say in the first possible option, we place the queen here. And then when we do backtracking, let's say we want to try other options. We want to remove the queen from this position and then try to place the queens in other positions. So that's kind of why we have those lines of code to make sure the backtracking is done properly. So now we talk about the part for visited. So we also need to talk the part with, where we need to return. Let's say if I equals to n, so which means, okay, we start from the row index 0, and then we finish the row index n minus 1, and then when we call helper I plus 1, we are entering the value that I equals to n, so that's kind of return. We already finished traversing and place the queens on the board, so we just need to add this configuration to the results. So in that case, result.append. So let's take a look at the output format. So we append a list, and in this list, it's actually the string. So dot join row for row in board. And then we just return. Okay, now what we need to do is to call the helper for I equals 0. And then after that, just return the result. So let me run the code. Okay, so here is our solution. If you liked my video, please subscribe to my YouTube channel. Thank you.